Welcome to today's lecture. Let's hope that everything is working as expected. I had to quickly switch from one meeting to the lecture, and now I hope that everything is working out fine. If anything is wrong, like the volume is too loud or anything, just let me know and I will correct this. Okay. So let's start. I have prepared a Menti, it seems. That's why I have this empty slide here. Let's see what I have here. Menti, my presentations. Let's see. And why are you not seeing the Menti? If I have prepared a Menti, you should also be able to see the Menti. So maybe I should open the Menti also on the computer. Yeah. Now it seems to work. So I will move this Menti down here. So you should be able to see it then. And now you should, you don't see it yet. Let me just select the Menti, this one. Now you can see it. Perfect. Okay, so I was a bit late with getting the setup done because I was in a meeting before. So let me open also the Menti mode, and I will then start a question right away. Okay. There are already 5 questions. Let me just briefly check them. Where you were swimming in the Among Us channel? I want to thread join that. Saturdays, it's on Saturdays. Is there a bonus for submitting early? If so, what are the max coins that I can get? I think the max coins that you can get is 50 per assignment. So 50 that you can get. So let's just minimize this window here, then I have focus back on my slides. How many hours is the limit? I think it should be 50 hours then. Does it matter if I submit 3 days earlier or 2 days earlier? Actually, this would make a difference because this would be 48 hours and this would be more than 48 hours. So it would make a difference. Okay, let's mark this as answered. The game is pretty tough to play. Do we get bonus coins for a good high score? Unfortunately not. Menti reactions are not visible in the stream. I think they are now. What is the best resource to read about the Posix standard? How do I implement code according to the Posix standard? We will learn a lot about this in the entire lecture. So this is probably the topic that goes through all the lectures throughout the semester. We will look at the Posix standard. Also something that I need to fix on my side. I don't see your chat right now. So let me just rearrange the windows here. Now I can also see your chat messages. Man pages, yes, man pages is one way how you can get information about the Posix standard. Or just Google Posix and then whatever function you want to work with. Menti reactions are not visible. Now they work. Are you a student? Is there a good club to make party? I am actually subscribed as a student of software development, but I haven't passed many courses yet. We have to pass an allocated pointer to enemy snakes, enemy mice, but there's no safe place to free it again since the thread gets created later. This is a question to ask in the assignment channel, so I won't cover that here today. Where will we get access to A0 on Wednesday? This will be in the test system. You should already have a login for the test system where you see the high score list and everything else. And there should also be the questionnaire. And there will be an additional link at the top, and that's called quiz. And this is the A0 quiz. Okay, I have trouble submitting A1. Should we already be able to do that? No, because I haven't set up the test system yet to be connected to the repositories that you just received this morning because I was in a meeting all this morning. How long is the time limit to upmelden? If you don't submit anything, you don't get any grades, so you don't need to deregister. How will A3 be done this semester? We will have some groups that take place in person if possible, and maybe some groups online. So let's see, but maybe also no groups online could also be. but certainly some groups offline, because the offline format is just so much easier to handle. Okay, more questions. Will there be Abgabegespräche? Yes, of course. Will we get more information on the questionnaires? How will they take place? Well, there's a questionnaire that you can all the time take. It's a self-assessment quiz that gives you bonus points, basically. You can do that anytime and get the bonus points. Okay, let's see. We have some questions, and I would like to know from you, the courses that you attend this semester, do they take place in the lecture hall only or online only? Just to know where we are. So some people, well, if it's in the middle, this would be 50-50, right? 50% of the courses take place online, 50% offline. Okay, so there's still a large shift to online, and probably this is due to the amount of people that we have. Yeah, also in the chat someone says everything is online. It's really unfortunate. I prefer the offline format because it's more interactive, but I can't fit you all in a lecture hall. So we are 360 students, so I would have to reserve a lecture hall for 720, and 720, we don't even have a lecture hall that fits that many people. So very, very unfortunate. So let's see, there have been, 93 people have voted in this already. So let's continue. I would like to know, where are you right now? So probably most of you are maybe in Graz, maybe some of you are at university, maybe some of you are abroad. So maybe, yeah, home, bed, okay, couch, Graz, yes. You can also enter multiple answers if you like. In a hackerspace is also interesting. In my flat in Graz, my room at home. So most people appear to be watching the stream right now from home in Graz. Okay. Any people from abroad? Let's see. Someone in quarantine. That's at the sea. Very nice. At the sea. What better thing could you imagine to be doing right now if you're at the sea than watching this stream? Isn't this great? So let's continue with the presentation, and thank you for all these answers. So we will let me check. Last time we stopped at the first man page at fork. And I will pick that up right there again. Not this one, the next one. Here, fork. And we also went through this man page, and I want to do that again because practicing to read man pages is a good idea. They are pretty dense with information, and this is also what we need to practice here. The fork function shall create a new process. It creates a new process, we remember that. A new process, child process, shall be an exact copy of the calling process, parent process. Okay, we have a parent process, a child process, exact copy. Okay. And they should be an exact copy, the child should be an exact copy, except for some of the details here. A unique PID, the child gets its own PID, then its own copy of file descriptors, the semaphore state is copied. We also talked about threads. Threads are not all copied, only the calling thread, it says here that only the calling thread, only a replica of the calling thread is copied into the new process, but the entire address space is copied. And this might include the state of mutexes and other resources. The parent and child, they should run independently of each other. Okay, so let's take a look at the return value. It also says in the man page, I will show that later to you when we live program something. I will show that to you that this is also exactly the information that we have in the man pages. Upon successful completion, fork shall return 0 to the child process and shall return the process ID of the child process to the parent process. Okay, so let's rephrase that in our own words. That's always a good thing to do if you read the Posix standard or the man pages. Try to rephrase those sentences, express them in your own words, and see whether you understood them. So in this case, I would say the parent gets the PID of the child and knows the child. The child gets 0, so it doesn't get the PID of the parent, doesn't know the parent. Okay. Both processes shall continue to execute from the fork function. Otherwise, -1 shall be returned. Okay, so this is, let's stop at this sentence first. Both continue at the fork function. So I call fork somewhere in my code, and then from that point, both of them separately continue. Otherwise, -1 shall be returned to the parent process. Okay, this is a very unlikely case, I guess, because why wouldn't fork be able to create a copy of the process? And then, in that case, no child process is created, and error shall indicate the error. Error is a global variable that you can use all the time. Maybe I should move myself a bit down because I'm a bit too far up today. No, not all the windows, just this one, a bit down, because otherwise I'm very far at the top. So let's see. Okay, so here we have a concrete example, and this is basically what you can copy for the exercises already. So you have a PID T child PID, then you call fork. This is the parent process. We are the parent process right now. We are calling fork, the calling thread, or this thread that executes this code calls fork, and then the child PID is returned to the parent process. And now we check what the child PID, what is written in this local variable. So if it's -1, then fork failed. Okay, that's clear. If the child PID is 0, then we know we are the child, because the child does not know the parent. And otherwise, parent knows the child, so otherwise we know we are the parent. And here we can use wait PID, another system call, another Posix function with the child PID. And with that function, child PID 0, 0, we wait for the child to die. Okay. So let's see. The parent waits for the child to die. That actually sounds pretty awful, right? But it's a bit like Star Wars, right? I never knew my real dad. Yeah, they all never knew their real dad. Yes, let's see. We have more functions, and we will get to know all these interesting Posix functions in this lecture, so that we then can use them. And basically, this is in the title of the lecture, System Level Programming. We're interacting with the system now, and for that we need all these functions that interact with the system. Fork is one function. With that we can create an exact copy of a process. But what use is it? Why would we need an exact copy of a process? And this is where exec comes in. Exec allows us to provide a path name or a file path name, and also some arguments. And with these arguments we can start a new program. We will take a look at exec VPE, which is the most complete version of this. And basically they are just variants of each other. So you can see here arguments. Here you can have a list, a null terminated list of arguments. And in this case down here, the arguments are an array. So it's the same, just a different interface, but the same functionality. So let's take a look at the most complete version here. So this most complete version of exec VPE, that's exec with arguments and with an environment variable, with environment variables. This supports all the features that we want to know. So what does it do? It replaces the running process with the process defined by file. Program file, process, instance of a program. You still remember that. So there you pass argv. Interesting. This is how argv goes into the main function, right? This is argv. We pass this through this syscall. And then on the other side, the main function gets exactly this array, argv. This is exactly the same array as the main function gets. Interesting. And then we can use envp and then the environment pointer or environment array. And there we can provide environment variables like path or other environment variables that we can set so that the program finds the stuff that it needs to find. For instance, if you want to type on your shell, you want to type something like ls or change dir, cd, somewhere else. This would usually use some binary that does that, or in some cases use a binary that does that. And this binary is maybe at /bin/ and then ls. Now, how does the shell know that it should be looking in /bin for this program if you just type ls? the path variable. This is what the path variable does. It looks up whether binaries are in there that you are trying to run. When we are able to create new processes and we are able to execute programs now, we also need to figure out how to exit programs. And the normal exit, you already know that. And I will turn down the volume a bit because it really shows serious clipping on my end. So I hope it's not all the time distorted. If it is, just write in the chat and I will fix the sound. There's also a question in the chat. We do not need fork for A1 and A2, right? That's true, but I wanted to explain programs, processes, and threads. And we are going now from programs that you already know over processes towards threads. So we will talk about threads a lot in the rest of this lecture. So there will be a lot of content on threads today. And this is what you need in A1 and A2. So let's talk about process termination. If you are able to create a process, you also should be able to terminate a process. You all know normal exit. For instance, if you return from the main function, that's a normal exit. You return with the return value of 0. Actually, if you return something that is not 0, that's considered an error exit. And this value will be returned somehow to the parent process, or the parent process can somehow obtain that. There are also fatal errors. And they also have these return values. So segmentation fault also has some form of return value that is returned to the parent process to indicate that it was a segmentation fault. We also have the option to kill another process, another way to terminate a process. All of them are ways to terminate a process. And you probably know all of them. Segmentation fault, I'm pretty sure you've all seen segmentation faults, whether on purpose or not. Maybe we will also see some segmentation faults today. Let's see. Some operating systems also have hierarchies with processes. For instance, on Unix or Linux, you have an implicit hierarchy based on who called fork, and then you have a parent process and a child process and a child process of the child, and so on. And this is implicit from calling fork. You also have process groups in Unix and Linux. In Windows, this doesn't exist in the same way, but also in Windows, you have some forms of process groups. So they are grouped together into security groups, for instance. There's an implicit hierarchy in Unix and Linux, and this is actually also documented in the man pages, but you can find your way around it a bit. When a parent dies, all children, grandchildren, great-grandchildren, and so on also die. But Linux cheats a bit here, because the parent process typically inherits a process's children unless the parent process does not want to. So let's take a look at a concrete example. And let me just get some air in here because it's getting a bit hot with all the light and everything. Okay, so git grep to do, and we pipe this into sort. This git grep is a very helpful tool if you want to search something in a Git repository. This is the #1 thing that I use, git grep, and then whatever keyword I'm looking for. Then I pipe this into sort because I want to sort them maybe alphabetically. Now, what does this do? The sort tool has to wait for the input, right? This gets the input on standard in. This one is piping the standard out into the standard in of the sort of the sort program here. So what does the sort program do in the meantime? It could loop and check, busy wait all the time. Is input already there? Is input already there? Or it can sleep and get woken up. Blocking the process here makes a lot of sense, right? You want to block this process until the output here is ready. And this is interesting now, and I want to ask you, and maybe you can answer that in the chat. Do we actually block the process here? Or do we block something else? And I will check the Menti for questions in the meantime. we only block the thread. That is absolutely correct, because we remember threads share the execution time. They divide the execution, the CPU time among themselves, but not the other resources, and processes only divide the other resources among themselves, but not the execution time. So let me just check. There are some questions here, and I will briefly hide the slides before we dive into threads. Whereas Hexe, she's not here, but she might show up later. I need a laptop. Which one is good for the course? Almost anything that can run Linux. Questions about the exercise interviews. Will we be asked about assignments we didn't do? Yes, you will. Because there's one part of this course is practicing, the other is knowledge. For the exercise interviews, you have to prove that you practice. So you have to prove that the parts that you practiced, you actually practiced, but you also have to prove that you have acquired all the knowledge that you need to pass this course. So if you need a laptop, get one with x86. Yes, that's a good idea, but ARM should in principle also work. That would be fine. It doesn't really matter which processor. New structure, quite different from last semester. No, it should be the same structure as last semester. When do is use the busy wait loop and check, and when the sleep and awake approach. Busy wait is very inefficient, so we never want to use busy wait, and that's also what the program here does, is it will actually put the thread asleep and only wake it up when the input is ready. And we will talk about threads now, because now we ran into this problem that we now heard that we are not blocking the process. Okay, let me just put the focus on the right window again. And now we need to understand what threads are, because once we understand what threads are, we can also use them in very efficient and creative ways. Threads are much more lightweight than processes, but they are also less independent than processes. So there's a bug on the floor. Just came in through the window. So this is less independent than processes, and there's no protection. So one thread can access the data of other threads because they are not isolated from each other. For processes, one process cannot access the data from another process in principle. So this is a stronger isolation. There's a comment, better to have a bug on the floor than in your program. I guess it depends on the type of bug, but this one is fine. So that's good. Why would we use threads? Things should happen in parallel, right? You want to have things happen in parallel, even within one application. For instance, a text editor. Take a text editor, you want to type, and at the same time, you want to spell check maybe. You maybe want to format something on the screen. You want to save something automatically. These things should happen in parallel, and they might block. And this is difficult then. For instance, a mouse click, waiting for a mouse click or a keyboard press. You know the function get character, get char. And you know that this one blocks, so you can't do anything in the meantime. Waiting for the disk, if you read something from the disk. So why do we use threads? To make programming easier. We have different tasks in our program, and we split these tasks into different blocks, pretty much like with processes. And now we have threads that split different tasks into different blocks. And they, because they are within the same process, they can cooperate easily within this shared address space. This consumes less memory, it's more efficient, but also here maybe this is something to highlight, because many students misunderstand this part, and this is especially relevant in A3. So I'm giving away an important hint here on A3. Do not confuse shared memory between processes with shared address space between threads, especially if I'm talking about a variable in shared memory. This does not mean a variable shared between threads, because all variables are shared between threads. All variables a thread can access any variable in the program. So there's no difference between them. There wouldn't be any non-shared threads. Shared memory, whenever we talk about shared, we mean shared memory between processes. So this is important for E3. Switching between threads is a lot faster than switching between processes because threads share the address space. So we don't have to switch the address space when switching from one thread to another. This is great. No need to reconfigure the memory, and this can achieve a better performance. And we have some illustrations here that I copied from somewhere. I can barely recognize what that is. So this is an example of worker threads and dispatcher threads and the web server. But let me take a look at this code here instead. So we have some loop here, loop that gets the requests. So this is one thread, and it gets a request and hands off the work to some worker thread. And here we have these worker threads. We can have many of them. They wait for work, then they search the page in the page cache. If it's not in the page cache, they read it from the disk. And then they return the page to whoever requested it. With threads, this is super easy because we have one thread here, one or more threads here. And this can then serve the website to a user that requests the website. But without threads, with just one thread, it's complicated. This program structure will get really complicated because reading content from the disk may block. Also, you don't know whether there is a new request. So you have to rewrite everything to be non-blocking, and this gets really complicated because then you get the next event. If it is a request event, then you check whether the page is in the page cache. Otherwise, you have to load it from the disk, and you save the request that you requested this page from the disk in the table, and later on this has to return on its own because the operating system then has to handle that, or we handle it later by handling our own request. But we have to basically serialize everything into one buffer, and we're doing work here. This is very simplified, of course. We're doing work here that the operating system is already doing. So we are doing that stuff again. We shouldn't be doing that. We should use threads instead. Could you rewind the section about processes and threads sharing memory between each other? We will talk about that more, about processes and threads and how they share memory between each other, but this will be later in the lecture. For now, it's always good to already hear bits and pieces about it, and later on we will complement that with more in-depth knowledge. So what we are actually building here is a finite state machine. We are actually simulating threads. Better, we just use multi-threading. That's the better idea. And how can we use multi-threading? And this is where it becomes interesting for assignment 1 and 2 is pthread create. And what do we have here? In pthread create, pthread t pointer thread, const pthread attribute t. Okay, so the const, that's a const variable pointer attribute. Wait a second, what is this? Void star parentheses start routine parentheses. What the heck? I don't even know what this is, right? So let's take a look at this. This is called a function pointer. And this looks wrong, right? This looks completely wrong. Yeah, let me fix that for you. Now it's better. So, of course, now it's better because now we have the void star, because the star always belongs to the data type, right? You know that because it's a void pointer, it's not void, and then a pointer, it's a void pointer, that's the data type. And then we have the start routine here. Now it looks totally fine, right? Much better. So let's talk about these function pointers. So start routine is the function pointer name. That's actually the variable name here, or in the case of function argument, it's the argument name. Okay, so let's divide this further. We have to divide this into smaller parts until we understand what a function pointer is, how we write it down, and how we work with that. And we will be there in, let's say, 10 minutes. So this is Totally fine. You will all understand that in a second. So let's talk about the type. So we remove the variable name. You know that when you cast something to a type, then you don't put the variable name in there, right? So the type of this is a void pointer. So actually you start reading this in the middle. So this part indicates that this is a function pointer. We are talking about a function pointer because this thing is in the middle. This function pointer as an argument takes a void pointer, and if we take a look at the front, it returns a void pointer as well. So this is what this function pointer does, and we will talk about more function pointers now just to practice this. So let's take a look at this one, function pointer. So if we want to define a function pointer for this one, we start off with this. This is the basis for every function pointer. We always start with this when we define a function pointer. Then we want to provide the arguments. So we add a parenthesis for the arguments, and it looks like this. Function pointer. Okay. Now we add the return type. The return type is int. Now it's int function pointer that takes no arguments. Now we have to add the arguments, and that's the first one is int, first argument, int. This is a function pointer that returns an int and as an argument takes an int. And the second argument, the character pointer array. So it's a function pointer that takes an int and a character pointer array and returns an int. Okay. Function pointers. I really like function pointers. They are very powerful. And actually, once you understood how they are constructed, fairly easy to understand. If it's difficult for you right now to understand them, just ask a question and I will check them on Menti right now. And in the meantime, you can already start thinking about this interesting case here. Start routine. So we have a local variable, start routine. It's a function pointer that returns a void pointer and takes a void pointer. And I want to assign the address of main to it. Let's see what happens if we do that. Here's a question. If my game runs perfectly with make run, I should be done with the assignment. Right. The test system will also show you your points as soon as it's ready, and then you can absolutely be sure that you are done with the assignment if you got all the points. There is a question, can I use code from last year? Well, if you haven't shared it with anyone, if you have shared it with anyone, knowingly or unknowingly, then it's pretty risky because you might be detected for plagiarism then, although it was your own code, but we cannot know. If you shared the code from last year with anyone, then it's difficult. The deadline for A1 was on 8th of October. At which time? I think it's 23:59 always, but it should be written on the rule page on the website. There it should say exactly what time the deadlines are. And I mentioned in the first lecture that you should read the rules page. It's really important. Otherwise, there are several pitfalls that you can fall into and get 0 points, so you should avoid that. If we fail the exam but have enough points from the Übungsteil, is there a chance we can retake the exam, or do we only have one chance? There will be options, yes. Why is there no synchronized keyword in C like in Java? Well, who implements the synchronized keyword in Java? Someone has to implement that. And I mean, you want to learn now how that is done. So let's see where this question is. I can't, yeah, here it is. So let me continue with this one. When we call fork, that means the parent process calls the child process. No, that means that the parent process creates a child process. This child process didn't exist before. Does it mean that when we run the program for the very first time, the parent process is already started? Yes, you start you run a process, you call fork, and at that point, the child process is created. Who starts the first process? The operating system starts the first process. Yeah, and in the chat, someone corrected my statement. So on the rule page, it says 1759. So it should be 1759, the deadline for all assignments. When will we learn about the one thing C has, but C++ hasn't? the restrict keyword. I'm actually not sure whether we have to cover that in this course. Maybe we do in some later lecture, but this course is called System Level Programming, and we focus on things that are relevant for system level programming mainly. So, do the concepts of message passing and channels exist in C? Does C support async await? Can I have many jobs automatically shared by a pool of worker threads? Let's say, where is the question? No, I can't find the question. So let's say you can, but you have to implement all of that by hand. So all the message passing and all the channels. Someone has to implement that, right? If you are using that in some fancy language, in super slow language, like Python is awfully slow. And of course, someone has to implement this functionality then in C, so that you can use it without worrying about it. But here we learn how to implement such functionality. So the process is kind of like a machine, and the threads are its cogwheels. Would this analogy fit? Maybe, yeah, one could say that, yes. Let's see, show question, mark answered. Are the points shown the actual points you get? Yes. Unless you did anything to trick the test system, yes, then it would be the points that you get. But yeah, the tutors would tell you. But how to recognize this main, that main is a function pointer? There was no star. Well, in this example here, main, this is a function. This is not a function pointer. But if I take the address of a variable or a function, think about a local variable. You have a local variable, int. That's not a pointer, right? But if you take address of this integer, this local variable, then it's a pointer. Then it becomes an integer pointer. And then you can assign it to an integer pointer variable. So can we just cast a function pointer to void pointer instead of void? I think you would get a warning, because pthread create expects a void function pointer that returns a void pointer and takes a void pointer. So this is what pthread create expects, and that is why you need to cast to this exact type. So a function pointer is exactly the same as a function, just without argument names. If you use a function pointer, you can use a function pointer just exactly the same as a function. So you can just call this function, then use it like a regular function. But the definition, yes, the definition doesn't have the argument names for the function pointer. But it has a variable name. This is not the same as a function name. It's a function pointer. It's a variable name. So why was the main function pointer? It had no star in the middle. Oh, what we wanted to determine there is the data type of the main function. A function has, like, even if you declare a variable, then it has a type, and also the main has a type. And for functions, it doesn't really make a difference whether you have a pointer or not. You can also omit this end here, and then you will get still the same thing. So if we want to test our assignment, do we just have to commit and the test system will tell us how good it is? Yes, exactly, but the test system is not ready yet. It will be in the evening. So I still have to link the test system now to the repositories. As soon as this is done, it will tell you. Can I use a Raspberry Pi 4 for the assignments? Yes, it should be possible, at least. Maybe not for A3. For A3, you should use Linux on a regular desktop machine. What are function pointers used for? Well, we will use them a lot in this exercise, but you will see that then. Does the start function need a void pointer as an argument, or can it have no argument? It needs a void pointer as an argument. Okay, will you stream on Twitch also games or something else? No. What is void pointer. Void in C means that it's you don't want to specify what type this memory location will have. A void, it usually only makes sense together with a pointer, and that means a pointer of any type. The thing is, a pointer always has the same size. A pointer is always the same size. A pointer is always just a number telling you where in the memory things are. A void pointer has the same size as an integer pointer. Same as a double pointer. Same as a pointer to some class or something in C++. So it's always the same. You need the same amount of bytes for these pointers. And this is one way to say, well, I just need some pointer. I don't care which one it is. So let's see. So do we have to cast the function pointer to this exact type every time we use pthread create? Yes, or you create a function which has exactly that type. This is why we are discussing this for main also, which data type does this function have, to determine do we have to cast it or not. Yes, will it return an error because main's data type is int and the args are either non-consistent or int char? Yes, not non-existent or int char. Yes, it will. We will see that in a second. Let me just go through the remaining questions. Will it be possible to change the deadlines to 23:59? I will discuss that with the tutors, and if the tutors agree that we can do that, then I'm fine with it. But if they have concerns about that, I mean, the test system also has other lectures that it will test, and it might collide with other deadlines if we move it. And this would be a drawback for everyone, because then you submit something and you might have to wait several hours until you get a result whether your submission worked. So if it collides with another deadline. So this is why maybe we picked 59, sorry. Why don't you use GitLab to Graz AT? It supports single sign-on. Yes, but we don't have the same flexibility in configuring the repositories. Is it better to change the Studium when I have problems with software paradigms and operating systems? Better to change to Sports Studium then? No, I wouldn't say that. There are always difficult classes in every course, and I think it's important. One important aspect of studying something is that you should be passionate about it enough to go through the entire program. And being passionate about the topic, yes, definitely one aspect. Of course, the other aspect is you can't, if you later on work in a job, you can't always say, well, it should always be something that you're passionate about, because that is not reflecting the reality of how working later on in industry is for most people, or for many people. But for studying something, you can, of course, take your passion into account, because you have the flexibility, at least in Austria, you have the flexibility to select from a broad set of topics and then get a good education in that topic. So void is nothing, and void pointer is a pointer to anything. Yes, it's a pointer. On the assignment pages, yes, 1759. It says 8th of October. Does it? So let me check. Just briefly what exactly we have here. So this is 8th of October. I will check the deadlines, whether we change anything. If we do, we will announce that. But I assume that it's that the deadline is October the 8th, so it's Friday, 17:59. So anything submitted after that would be after the deadline. So when will we have to make the first assignments or things? Already now. I mean, the first assignment deadline is in 4 days. I seem to have missed the login for the test system. Where can I get a new link to log in and set a password? You can use the password reset functionality. Just use your student.theograz.at email address and just use the password reset function there. Type in as login your student mail address without any typos. Click password reset and then make sure that you check also the spam folder just in case it is moved over there. What do the arguments for pthread create do to a thread? I'm just passing null. We will also show that in the lecture. We will see that. What can be the reason that I cannot see things on the online side of the lecture, but I'm registered for the course, so I don't see anything about deadlines and some things. It's on the website of our institute. So there's a lot of information that you should check out. Also all the assignment descriptions. Could you please okay, let's when is the deadline for A0 and where can we find the repository code? Also something that we don't answer here now. You can ask that in the Discord if necessary, and I will check whether I can still get rid of this question here because I answered this already. Yes, Marcus answered. We are going to get access to the slides. Yes, I also uploaded this slide deck already on the website. So let's continue with the presentation now, and we continue with this function pointer and assume we want to start a thread. And for this thread, or we want to assign this to a local variable, it's the same thing. We need to make sure that the type matches, but the type doesn't match. So what now? We need to cast it. So we need to cast it, and we do it like this. We want to cast it to a function pointer, right? So let's take a look at this one, the function pointer. So here we cast it to a function pointer that takes a void pointer and returns a void pointer. And we put this into parentheses to make this a cast. This is of course dangerous because if this actually can't be executed in this way, for instance, because the arguments don't match and either the function needs those arguments or whoever calls this function then will use this argument, this could lead to effects that you don't want. So you have to be really sure what you're doing there. Let's take a look at the Posix standard or the man page here for pthread create. Pthread create has many arguments and we will go through them. But we do that by reading through this man page. The pthread create function starts a new thread in the calling process. The new thread starts executing by invoking start routine. Okay, so that means this function is the function that is executed by the new thread. You see what I'm doing again is I'm rephrasing whatever the Posix standard says, so to make sure that we have understood this, also to check that I have understood this. The start routine is whatever this new thread executes. It runs this function. Okay, and this thread is running in the calling process. So wherever we call pthread create, in the same process we will then have a new thread. Arg, the argument, is passed as the sole argument of start routine. Okay, interesting. And we understand that, right? The function is called with arg as a parameter. The attribute argument, points to a pthread attribute structure whose contents are used at thread creation time to determine attributes for this new thread. This structure is initialized with using pthread attribute init. Okay, there's a function for that, and related functions. If attribute is null, then the thread is created with default attributes. Okay, so maybe later on we will check out those attributes, but for now passing null is fine because it will then create a thread with default attributes, and they are usually fine for us. And we have more, like this is something that I always recommend. Don't put too much text on the slides, but the point here is we want to learn reading the Posix standard, so we have to do that together. Before returning a successful call to pthread create, before returning a successful call to pthread create, stores the ID of the new thread. Okay, so pthread create stores the ID of the new thread somewhere in the buffer pointed to by thread. Okay, so let's take a look at the function signature again. Up there we have the, let me just move myself a bit up again so that I can actually point to this stuff here. So this thread variable up here, yes, you can see it, I guess. Okay, this thread variable up here, this is a pointer and it points to this pthread t. And here it says it stores the ID of the new thread. The thread ID is stored in this variable. So this is basically just a pointer to a number, a pointer to an integer or something. So pthread t will be something like an integer, similar to an integer. So this is interesting. So this is something we know already from programming 1, from Introduction to Structured Programming. It's a pass by reference in C. We pass a pointer because we want to change the location that we have there. The identifier, the ID, the thread ID, is used to refer to the thread in subsequent calls to other pthread functions. Okay, this is interesting. So that means that we can later on use this ID and then we will refer to exactly the thread that we created here. So let's go through these arguments again. We have the pthread t is the thread ID, pthread t pointer, a call by reference as we just said. Okay. And we have the attributes where we pass null for now. We have the start routine where we tell which function to execute, and the arguments where we can pass an argument that is exactly the size of a pointer. So for instance, a pointer or a number that has exactly as many bits. Okay, let me just briefly hide the slides and we will check out questions on Menti, because there are again several questions. Can you partly cast function pointers? For example, only cast parameter type but not the return type? No, and when you cast something, it has to fully match. So you have to fully write down the full data type that you need. So does void pointer allow every type? Well, if you cast something, everything is allowed, right? You could also cast a function pointer to an integer pointer, and it would have the same meaning. If you have a pointer, whatever is in front of it doesn't mean anything for the processor, for the computer itself. It just means something to you as a programmer. So this is just whatever is written in front of this star is just for you syntax sugar. Discord link again, it's on the website. How do you switch between the GitLabs in Termination? I'm not sure what you are referring to here. So our GitLab is a separate website that you can use. What if I have more than one argument for my function? I mean, there is only one argument in pthread create. Yes, but it's a pointer. You could make this a pointer to a struct, and in a struct you can have many members. You can make it a pointer to a class. You can make it a pointer to an array, and this way you could provide more data to the function. So star thread contains the number of the thread ID is a number, and star thread, if you would dereference this memory location, it would contain the thread ID. That is correct, yes. I used void pointer function in A1 and it worked, but it's not a full function pointer cast. Why does it work? Maybe because you're not looking at the warnings that the compiler shows. The compiler should throw a warning if the pointers don't match. Okay, Mark has answered. And there's also one comment in the chat that says we need to cast it to void pointer with void pointer, function pointer, void pointer main, because main is not a void pointer, or simply to a void pointer main for pthread create. I think only the first variant should work without warnings. I think the latter shouldn't generally work without warnings if you enable all the warnings. Okay. So, how do pthreads terminate? Because we already talked about processes, how they are created, how we execute a different program in a process, and then how they terminate. But for threads, we only talked about how we create them, how we execute a function within a thread, but not how they terminate. And a thread can terminate in different ways. One way is calling pthread exit, specifying an exit status. And this is again copied. This is still copied from the main page. Specifying an exit status value that is available to another thread, okay, in the same process that calls pthread join. Okay, so there are two functions in here, and let me rephrase it so that we make sure that I understood it correctly. Pthread join, if I call pthread join with a thread ID of another thread, I will get the exit status, the return value of that thread that this thread provided with pthread exit. Or if the thread will also terminate if it returns from the start function, and this should be equivalent to calling pthread exit with the value supplied in the return statement. So when I call return, this implicitly will, let's say I call return 37, and then pthread exit will implicitly be called with the value 37. Or you can cancel a thread. Same as you can kill a process, you can also cancel a thread. So we have the same mechanisms here for threads as well. We will talk more about cancel later, not today, but we will talk about them. So what exit values are there in pthread exit? Well, the exit status is the number, or basically it's a pointer, it's a void pointer. You can provide any value that fits in a void pointer there. There's another option how a thread can terminate. If any of the threads in the process calls exit, because exit, we know that, terminates the entire process. And that means all the threads have to die. Or the main thread performs a return from main. If the main thread, it says main thread here, but I really don't like this terminology. Let's say the thread that runs the main function. If that one performs a return from main, then this should happen. This causes the termination of all threads in the process, but also it's clear why that is the case, because the C standard says if you return from the main function, if you return from this function, it should be as if exit is called, and in practice exit will just be called. Let's talk about pthread exit in more detail. So pthread exit, again, we're copying this from the main page. The pthread exit function terminates the calling thread. So whoever uses this function, this thread is terminated. We can provide our return value here, and it's a void pointer. And this is interesting because this fits exactly to the return value of the pthread create, of the function pointer in the pthread create call. Terminates the calling thread and returns the value via readval, this one. That, if the thread is joinable, okay, we will talk later about joinable and not joinable, but not right now, is available to another thread in the same process that calls pthread join. Okay, let's rephrase that. We can call pthread exit, and then we will return with whatever we provide as an argument. And another thread can use pthread join to read that value that we stored there. So it allows us to store one value when returning or exiting a thread. After the last thread in a process terminates, the process also terminates as by calling exit with an exit status of 0. So that means if all threads in a process, let me rephrase it, if all threads in a process called pthread exit, then the process will exit with status 0, exit 0. Okay, let's talk about join and cancel. Pthread join, let's take a look at the signature here, and you will already realize there's a difference to the previous case with pthread create. Here's no pointer. Why do we not need a pointer here? And this now becomes interesting here. Void pointer. Why do we need a pointer? It doesn't make any difference, right? Anything that is in front of this star here is just syntax sugar for you. And yes, in the chat, both of you are right, all of you are right. We do not modify the thread ID, and that means we don't need to modify this memory location. We're just reading the value. Correct. And return value, why do we need a pointer here? pthread exit, we returned a void pointer there. And this is something that I find very confusing at first. Very, very confusing. I found it very, very confusing in the beginning. Whenever you see a void pointer in the POSIX standard or in the man pages, it doesn't mean void pointer as in this will be a pointer, but it just means an arbitrary, on our 64-bit systems, an arbitrary 64-bit number. This is a 64-bit number. And if we say void pointer is just a 64-bit number, then it makes sense why we need this additional star here, because void pointer is actually a 64-bit number, pretty much like size t or a long int. We could write long int here. And then it's clear why we need a star, because we need to, we get the address of this void pointer. And let's see, in this example, the address of this void pointer. What are we doing here exactly? Let's maybe read a bit. The pthread join function waits for the thread specified by thread to terminate. Oh, so we can call this before the thread has terminated. So we call this function. Let me just close the window because it's I think it's got a bit loud. So pthread join. We have this pthread thread here. And this, it waits for the thread specified by thread. So this thread ID, it waits for the thread with this thread ID to terminate. Interesting. If the thread has already terminated, or whenever it terminates, right? As soon as this thread terminates, or if it already has terminated, then we use, then pthread join will return immediately. We immediately return and get our return value here. The return value here, we will take a look at that in a second. But it's not the return value from the thread, because this is an integer. It will just tell us, was it successful or not? Why do we have the void pointer here? Well, so we want to store the return value somewhere. So we create locally, as a local variable, a void pointer variable, and pass the address of this void pointer variable by reference to this function, so that the thread that terminates, that uses exit, can write the void pointer into our void pointer variable. That is why we need a void pointer, because void pointer here just means it's a number. We have a local variable for a number and we pass this by reference. It's another pass by reference. There are several comments in the chat. I didn't quite understand why we use void pointer. Hopefully it's now clearer that I clarified that this is a call by reference again, and void pointer just refers to any 64-bit value in this case on our 64-bit machines. The thread returns a void pointer red value, so this could be an array, for example. This is why we want a void pointer. No, I would not say that's correct. We want the void pointer because it's a pass by reference. Is this the same as size t pointer? Yes, excellent comment. When I would write this standard, I would not write void pointer here. I would write size t pointer, because this would be the same. And I create a local variable size t redval, and I want the return value of the thread to be stored in there. How do I get it in there? I provide a pointer to this size t, to this function, and then this function can write the value into this size t. But because the designers of this standard didn't want to use size t here, they used void pointer instead, which is maybe a bit more broadly applicable, because it's part of the standard, right? You don't need to include a header to use void pointer, but you need to include a header to use size t. So if I would have written a standard, I would make size t standard everywhere and use here a size t pointer. So this is not actually a pointer, whatever that construct would be. There are rarely useful scenarios for pointer, and so on. It's a pointer. Whatever is in front of it, I don't care. It's a pointer. This is the only thing, this star, and that's true for every pointer. This star is the only thing that defines this is a pointer, everything else doesn't matter. This is the only thing that defines that this is a data type. Pointer. So Spinlog is right. it is the same as using size t pointer here, because void pointer is a number, not necessarily a pointer. It can be a pointer because a pointer will fit into a size t, but it doesn't have to be. When will there be some live coding with threads? Pretty soon, because I only have 7 slides left. So let's take a look. If redval is not null, then pthread join copies the exit status. Yeah, now it makes sense. So I can pass null here. If I say I don't care about the return value, I can pass null there. But if it's not null, then pthread join copies the exit status that we have seen here on this slide here, pthread exit. This exit status, which again could be size t redval, copies this one into the memory location that we are providing here as pass by reference. So let's see, copies the exit status of the target thread into the location pointed to by redval. Great, we already understood what this function does before even reading the text. We should still read the text because sometimes it says something unexpected and then we want to know, right? If the target thread was cancelled, then pthread cancelled is placed. So this is a constant, it's a number. And this number is then placed in the location pointed to by redval. Okay, so that means that, if someone used cancel on our thread, then this value is written to this location. And this is a number. This is not a pointer, but it's still written into this void pointer because this void pointer doesn't mean anything but size t. It's a number variable, a number that is exactly as large as the register size of this processor, so 64-bit for most of your systems. We will talk about pthread cancel, and after that we will go over to live programming, and I hope that my screen share setup works. If not, I might need 1 or 2 minutes to make sure that it works. So we have pthread cancel here. It takes a thread as an argument. Again, why is there no pointer again? Pthread cancel cancels the thread. No pointer. Pthread t thread. Because it doesn't have to change the PID, the thread ID, the TID. It doesn't have to change it. It just needs to read it to know which thread to cancel. Yes. The pthread cancel function sends a cancellation request. Okay, so it asks the other thread, apparently, to the thread. So what the cancel function does is it goes to the other thread and says, please, can you kill yourself? And the other thread will go like, okay, done. And that's how pthread cancel basically works. Okay, so takeaways before we go to the programming part, and this is now just we concluded now the part where we explain things on the slides, and now we will, for the remaining, how much time do we have left? Let's say 35 minutes roughly, we will live code then. Processes. This is the takeaway from the last lecture and also this lecture. Processes divide resources among themselves except processor time. Threads divide processor time amongst themselves and a few other resources that you need to work with processor time, but mainly processor time. Sometimes processes are more appropriate and sometimes threads, and it depends totally on the use case who needs to interact in which ways. And with that, we are at the end of the theory part here. Well, as far as theory goes here. And we will check the questions on Menti one more time. Casting the function pointer to void pointer in A1 doesn't throw any warnings, but it's only the argument doesn't match the type. The function pointer is already of the type void pointer. I think you still need a complete cast. But maybe the warning flags that are used there are not the most restrictive. Are threads cancelled using hashtags? No. What's the difference between pthread exit and cancel? Pthread exit, the thread on its own decides, I don't need to run anymore, I will terminate. And pthread cancel means, this other thread shouldn't run anymore, I will terminate it. So the one is myself, the other one is others. can I make a thread, well, if you dereference the thread variable, then it's certainly not a pointer anymore. Can I make thread point to struct instead of thread ID? No, it's always a thread ID. This is defined by the standard that it's a thread ID. When I have a 1, I need to make a 2 in a group. No, all of the assignments are done in single person teams. Well, I mean, you could argue that it's then not a team, but think about it. Teamwork often means you just have to do all the work, doesn't it? Would git config global override the already existing config to the GitLab of ESP? Well, git config global is only used for things like the email address or the name or something. If you override that globally, probably it makes sense. It wouldn't change the repository path or anything that you use for other lectures. Also, I'm not to judge here, but ESP. I hope that most of you don't need the ESP repository anymore because you already have completed that part. Do we need pthread exit in A1? Could be. I don't know. I don't want to give away the solution, but it could be one way to exit threads. But there are more ways to exit threads. A question was asked because in DC, but we were told to use other methods to terminate the thread. Yeah, it depends on what exactly you want to do. If you want to terminate another thread, then pthread exit will not help you. Then you need to use something like pthread cancel. Which things should we have a closer look at so that Valgrind throws no more errors when we use threads? Oh, this is a tricky one. This is tricky, especially for assignment 1, because, and I don't see the question on my phone, because the framework already has memory leakage. So maybe for assignment 1, it doesn't matter, but I would check that with the tutor. Ask them, do you check with Valgrind? If they don't, then you're fine. Okay. Wann können wir die Questionnaires machen? Questionnaires should already be open, but a zero quiz is on Wednesday. Are we allowed to use all libraries? Well, not all libraries, but we also don't have any specific restrictions. If you have any questions about libraries that you want to use, whether you are allowed to use them, just ask the tutors and they will tell you. That's very easy. You can also ask questions like that in the corresponding assignment chat and make sure that the tutors will tell you, okay, and then you have it in text written that you are allowed to use that library. But also in the chat it says you are not allowed to include something in A1. Yeah. Okay, let's see. Will you show those who don't know how to set up GitLab SSH and GPG keys? No, I won't show that, but we have a tutorial for that on the website. How many points will we lose if we don't GPG sign our commits and tags? You don't need to GPG sign them. You just need regular commits. Only you have access to the repository, and that's good enough then. Is there an exit value for pthread cancel? Yes, there's a constant. It's called pthread cancelled in all uppercase. But you can check out what pthread cancel and this constant actually do by typing into your command line right now man pthread _ cancel. Is void pointer to a pointer? Maybe, but most of all, it's a pointer. What it points to, well, that is what the programmer defines. Pthread cancel, get the confirmation that the thread will kill itself right away or after the thread is killed. Pthread cancel, there are two different ways how you can set up pthread cancel. We will also talk about that more in the lecture, maybe, but at least about the parts that are relevant for the exercise. So one option is to wait, the other option is to immediately return, and then the thread will kill itself as soon as possible. Can a child cancel its parent? You might have noticed that for processes I spent some time talking about a process hierarchy, but for threads I didn't. And also, no one called the thread that created the other thread a parent thread. It always said the calling thread. Threads are all equal. There's no hierarchy among threads. So let me see. Mark answered. When is the deadline? Friday, 6 p.m. Are third-party libraries permitted? Depends on the library you are and the assignment. You have to ask the tutor for that. Can you explain again what the questionnaires exactly are? Self-assessment quizzes that you can do anytime. As IND, you might need it in the last assignment, assignment 6, but maybe not. Depends on the assignment 6, but you can check out the description in the wiki or in the website already. When can we submit A1? Is it already possible? Yes, and later today, so tonight, the test system will also acknowledge that and show in the test system that you have successfully submitted A1 if you try. Why don't you like main thread? Because main thread sounds like it has some special role. It doesn't. It's not a main thread. It's the thread that was started first. It's the thread that runs the main function. But it's not the main thread. Actually, we saw that last time, that it starts in another function, not the main function. So the main function just happens to be one of the functions that it executes. A more appropriate name would be the start thread, because it started the process, or it was the starting thread in the process. Wenn die Questionnaires schon offen sind, wie speichere ich dann meine Antworten? There should be a submit button for the answers. There's then we have UI thread. UI thread, yes, a UI thread. Often you have a UI thread in a program. Do we have now everything? Yes, you have everything for A1. You already have that since Friday, because you only need the code, and that was in the upstream repository. That is linked on the website since Friday already. What exactly is the start function? The start function is called _start, and we showed that in the last lecture. So if you are missing that knowledge, just check the lecture from last time. There we talked about the start function and showed what it looks like. Wo ist Hexe? I think she's not there here. Let's try. We will see whether she comes here. So all threads are born free and equal in dignity and rights. There's no main thread. Yes, exactly. Can we do questionnaires anytime, or do we have a fixed time, or are they optional or mandatory? Questionnaire is optional and you can do it anytime. So let me mark these as answered, because we need some time to code. And I will sit down here and I will... Oh, now you can't see me anymore. Well, let's see whether you can see me now. No, you can't see me anymore either. Otherwise, now you can see me again. Okay. Actually, I might need to change the setup a bit here so that you can see me properly. Yeah, much better. So, but now I'm actually too large here. So I will just cut a bit away on this side, and then I will move myself maybe down here. Yeah, this is better. And then we want to see VS Code, right? Oh, this is not VS Code. What is this? Now I can see it. So this is my VS Code, and you can see it here, and I will move over the chat there. So, and Menti, you can't see the Menti anymore. Now you can see it again. Okay, and I will move the Menti maybe, no, I will keep it here. So, let me also move the microphone a bit more so that you can hear that better. And I will turn down the volume a bit so that I'm not too loud then if I'm very close to the microphone. Okay, so let's see. Why don't I use dark theme? Because it's actually for my streaming setup much better. Because if I can show you what happens if I hide my webcam, then this happens. So this is the setup that I'm using. You actually don't see the white background of the editor here, but you see actually the white background of my wall behind me. So let's run some code. I prepared some examples here, and we will create a new example. We will play around a bit with threads. Thread C, okay, we need to start int main. I always start with int main return 0, and let's see whether this compiles. So we maybe compile this minus w all, and then it's the thread.c, and the output file maybe I call it thread, and then I also want to run it and thread. Okay, this seems to work. Well, I just wanted to have a very minimal file at first so that I know that everything is working so far. I will now include standard.io.h to use printf. If I don't know which header I need for printf, I can directly show you the first interesting part, man printf. This is the wrong one. This is printf in man page 1. We want printf in man page number 2 or 3. So let's pass a 3 here, man 3 printf, and here we get the Linux programmer's manual, and there we get printf, and there it says include standard IOH. Okay, so we do that, printf, and then we can say here hello world, and that's it. And we can hide this window again. If I should make the font a bit larger, maybe I should do that. I will make the font a bit larger so that you can read this more easily in the stream. I think the font size should now be well readable. Okay, so we have hello world here. And now as a next step, we actually want to add a pthread create, but I don't know how to call pthread create, so I will type in man pthread create. And here it tells me, interesting. Synopsis, I need to include this header. You can just copy paste it in. Copy paste this one in, and I will change this hello world here. I will change this to before thread creation as well after thread creation, and this is the signature, right? I need to change this. This needs to be a function call. So pthread create. We need to provide some thread variable. I will call it t. I'm very good at naming, right? Pthread. Oh, the pointer has to go to the data type because that's the data type. Okay, pthread t pointer t. Well, it has to be a pthread t, not a pointer. And we pass the reference there because it has to store the PID. And someone says the chat is too large, so that means I will scale down the chat, but I have to make it large enough so that I can still read it, because otherwise I wouldn't see your messages anymore. Okay, so pthread t attributes we read in the man page before we had that on the slides, right? And there we read that we can pass null there, and it was here. So this was exactly copy pasted from here. If attribute is null, then the thread is created with default arguments. I want to do that. Default arguments is fine with me. I can also pass null here. I don't have to provide this caps lock case of null. I mean, I prefer to read this number than null. Null always sounds like there's, I don't know, some death metal artist screaming at me or something. So maybe null 0 is also just nice. So let's then put the next things up here. Argument, we don't need an argument. Let's pass 0 there as well. Start routine, yeah, we need some function. Let's call it a thread function. And I will create this function here. I don't actually need any return value or anything. I just need a function. Okay, let's see. So we created this, and I will make this now a bit larger so we can see thread function. Yes. Okay, looks good. I will run this code, I think. I will just run this code. I will remove some new lines so that we have some more space here. I will compile this. Oh, this did not work here. pthread tree. So there are several problems here. We didn't read the man page fully, right? So here it says compile and link with -pthread. So we probably should do that. So we have to pass -pthread here. Okay. Okay, it didn't get better. There are still more warnings. Warning, passing argument 3 of pthread incompatible pointer type. But we know what it wants. We know that it wants avoid. Oh, this is interesting. This already gives me the hints, but I don't need the hints. I can type this on my own. I want to cast it to a function pointer that gets a void pointer and that returns a void pointer. And that's what I cast it to. And then I compile this and it works, but it doesn't do anything. So let's maybe use printf here as well. Printf, I'm the thread function. And let's see whether this one does something. So, oh, no. I missed the semicolon. With the semicolon, it works, right? You can see it perfectly works. Very nice. Let me just... Yes, I like this one better now. Okay. So, should we not use end thread function? Oh yeah, we can also do that. That is actually more beautiful because we want the address of this function. But for function pointers, it doesn't make any difference actually. Oh, it does make a difference. No, it doesn't make it. Oh, can you see this? This is super weird. First of all, it prints this twice. And sometimes it doesn't print it. Now that is odd. Very interesting. So pthread create, and then sometimes it prints it twice, sometimes not at all. So maybe we should wait here. So maybe we should synchronize this a bit. And one way to synchronize things is to just have a function that blocks. Get character is a function that blocks. I like to use that one. Before thread creation, I'm the thread function. After thread creation. Seems to work. Let's try that again. I'm the thread function. After thread creation. Okay, perfect. This is not proper synchronization, but it at least gives us an impression of how things were, how things work. Is there any reason why you need to pass the thread function if it doesn't really do anything? At least in this example, besides the man page, I mean, well, if I don't pass anything, it wouldn't execute anything. It doesn't make sense to call a thread, yeah, if it doesn't do anything. So let's see. What else do we want to see? Maybe we want to do something useful here. I'm thread. Let's say I'm thread. I want to provide an ID here. So let's use size t. I'm a big fan of size t. So I will always use the size t. We can call this thread ID or short TID. We can print the thread ID here. I'm thread. This one, we use a ZU here, unsigned, and Z for size T, and that's the thread ID. And I will now create just a bunch of threads, because why not? Maybe 2 for the start, just to just gradually go from simple examples to more complicated examples. So for loop, and in this for loop we create the threads, and they have here the thread ID is just the counter. It's the thread ID. We can also make +1 if we like IDs that start at 1 better. Let's try that. Yeah, here. Oh, void pointer restrict. Let's see. So what does it do here? We need to cast this to a void pointer. Let's cast this to a void pointer, because why not? It's just a 64-bit number. Who cares? Sure. Let's try that. It works without warnings. It executes the 2 threads. Very nice. Okay. Do we need synchronization in A1? Hopefully not. You can solve it without synchronization problems. So I'm thread 1. Maybe they should do something useful. Maybe I want them to compute something. And I will have a variable here, sum. Sum in the beginning is 0, and they should sum up the numbers, let's say the numbers from size t, they count up from 0 to 10. Yeah, while I is smaller than 10. Let's make a constant for that. I like to have a constant for that. Max is 10. Okay. Yeah, let's add parentheses, because then that's actually better. When we use defines, always use parentheses around the thing that you defined, because then if it's used somewhere, you can't do weird stuff, right? Because otherwise someone could add a number or something in front of it or behind it, and weird things could happen. Okay, let's use this for loop. And we're just counting, and oh, I need to move this. This is the part that I really like. We need to make it a global variable. I like global variables. So this becomes a global variable. Sum is global variable. And they will just do sum plus plus. Yes. And then we can print the sum here. Sum right now equals sum right now is 0. Yes, that works. And I will create multiple of these threads, and then I will check what this looks like. So I'm running this, and yeah, looks good. So they counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Seems to work. It really seems to work, although there are multiple threads. So let's do this with more threads. Let's think about it. With 20, we should count up to 200. Oh, wait a second. What is it? What is this? 194, 179, 195. This is okay, so I'm not sure what this is, but this doesn't look right. And also the result is not right. Okay, this is bad, right? So how bad does this get if I let them count a bit more? And maybe I don't print I can print every line, of course. I can print every line. Oh, this worked. Okay, interesting. Oh, now it didn't work. So apparently sometimes it works, and I will now use another thing you might not know yet, ULL. I will add ULL to this number. That stands for unsigned long long, because by default this would be an integer, and an integer only has 32 bits. There's a question by someone in the chat asking, why don't we need an include for size t? Because size t is already in one of these headers. It's already available through one of these headers. I think through standard IO. If I run this, let's see. Oh, this is now taking, oh, this will take forever. Oh, wow, now it's really off by a lot. 64. So this is really bad. We're actually losing numbers here. So what do we do? 1521. We don't have much time left. So maybe we take a look at one more case that is not this problem. This problem, we won't solve that today. That's too complicated for us to solve today. So we will take a look at something else, and maybe they will return the sum when they are done with their task. So I will just return the sum. Okay. That didn't do anything, but actually if I compile this, it should show me a warning. Yes, return with the value in a function returning void. So we need to return something here. Let's return a size t. Oh, that works. Interesting. Although, yeah, the cast, of course, we have the cast already here, so that's always fine. Okay. There's a comment in the chat saying lock the global sum. We will learn about locking in the next lecture. Not today. That would be too much for one lecture. We learned about threads so far, and threads are already difficult to understand. So I don't think we need to add more to that. So return sum. Okay, now we should be able to actually join them. But for that, we actually been overwriting this thread ID all the time. Let's make this an array. So we define the number of threads as 20, number of threads, and we will create an array here, number of threads. And now we know pointer arithmetics. We could use, for instance, this syntax here, right? We take the address of this array entry, but we know pointer arithmetics, right? We know that this here doesn't mean more than this, right? We can also write it like this, and then this cancels out. So we can also write t plus I. Why? Because we know that t at offset I is the same as star t plus I. And that means that address of ti equals address of dereference t plus I, and these cancel out. That means that address of ti is the same as t plus I. And we can also do other things here, right? Because you all know math, right? So if I say I go here and say, let's switch these around. You can try that in your own compiler and try what happens. So I should be able to then turn this around, right? Because now I flipped them. So I should be able to say address of this. And I should even be able to use I at offset t, because that's the same as this. Because the plus operator, you can turn the operands around. Interesting. Okay. So let's remove this small excursion into pointer arithmetics, and we now continue with this number of threads. Okay, we introduced this, we have an array, we provide this here, and we will now here I guess all threads are dead, all but me. I mean, this is the starting thread, this still lives. Let's check their return values, and then we will see when they are, what they returned. And we will use a function for that, and we learned about that in the lecture before. That was pthread join. Pthread join, include pthread h. We already did that. Link with minus pthread, and then we need this function here. So we copy that in. Okay. Pthread join. We need to provide the thread ID, so t plus I. Interesting. Now this won't work because t plus I is a pointer. We need to dereference it and take this offset. And in the chat, someone says this is illegal. I'm not sure what it is referring to. And we now need the return value. And now you will see why this void pointer stuff really makes sense, because we will have here our local thread redval variable, which is, let's say, -1 ULL. And this is just all bits set to 1, because it's the highest value that we can represent in an unsigned long. So it's definitely not the return value of this thread. And we will now provide this size t here, a reference to it. And if we compile this, so let's see, are we understanding correctly what this does? Pthread join copies the exit status of the target thread in there. Okay, if the target thread was cancelled, then pthread cancelled. So let's try whether this works, this part here. So we compile this. It says it doesn't like it because we provide a size t pointer, but it wants a void pointer. But we said they always say void pointer when they actually mean size t. So we cast this to a void pointer and it will be fine. Yes. We compile this, we ran all the threads, and now we will get their return values. Oh, it didn't work. Because we are not printing anything. Of course, we need to print the value. Thread, this one, thread 0 return value was 0. Okay, and there we provide this variable. Very nice. Okay, so we just print now what the result was. We run this again, and we can see that, this is super weird. Very weird return values. What do we actually return here? Return sum. Interesting. Thread return value. So this is actually, and the thread numbers are also weird, right? Take a look at these thread numbers here. This is super weird. Thread 150. I'm not creating 150 threads. Oh, of course, because I'm not providing the thread ID. This is nasty. So printf doesn't even warn me that I'm not providing the right number of arguments here. Huh. This is a stupid mistake, right? Okay, so let's provide I here, because I should be the number for this thread. Thread number, okay. Thread ID. Oh, then this was just printing some garbage stuff from the stack. Now it's better. So it's printing some values, and we can see thread 0 was the first to terminate at return value 25. Then thread 1 at 26, thread 2 at 32. And we can see exactly when which thread returned, when it was done. Okay, this is good. I think this is basically the part where we go back to the slides one more time, because well, the slides are done, but I have one Menti for the end, and we are at the end. So let's check out the questions. I don't think the cat showed up. I don't think she will come here. I think she's asleep somewhere. So let's open the Q&A again. VS dark theme, please. I can't code on the dark theme, because then you wouldn't be able to see me. So if I would switch to the dark theme, let's check theme, dark theme. No, where was that? I could color theme. Yeah, here. If I would do that, it would look like this. I would not be visible anymore. So this doesn't work with my setup. Of course, when I work on my own, I'm using dark theme as well, but I can't use dark theme while streaming. Okay. Okay. So don't use laugh tracks. So actually, this is something that I used a lot more last semester, and students really liked it. But if the volume is off, that is of course a problem and not intended. I will reduce the volume then, but I think it's some people like it, so I would tend to keep it, but I will turn down the volume if they are too loud. Okay. Could you do a Menti quiz more often? Yes, we still have a Menti quiz. That is Z-Shell for the win. Yes, you should definitely install Z-Shell. Let's see. Are there Visual Studio Code extensions you would recommend? I have a few Visual Studio Code extensions installed, but so most of the time I am actually working on scientific publications, so I will not have the same extensions installed that you would need for development, because I'm not coding that much. I'm more writing papers. So I don't see a submit button for the questions. That's odd. We will check what is wrong there. Here someone says more laugh tracks, please. So I will try to turn down the volume and coordinate that for next time, and then we will hopefully have best of both worlds. So it will be not too loud, and at the same, so that people don't that people are distracted by it, that don't like it, but people who like it will have it. So the Menti quiz more often. Why is this question not shown for me? Where is it? Here. Okay, let's close this. I will have a Menti quiz at the end. What do you think about Tab 9 and Kite? I haven't used those, so I don't know. One Dark Pro, it's probably the best theme for VS Code. I don't mind really, but I can't stream on a dark background. I need to have the white background because otherwise my setup would not work. Will the code be in the slides? No, it won't. What book do you recommend for this subject? I recommend coding, and you should, well, if you want to read something, read the man pages, read the Posix standard. There is as much content in there as in a book. But the thing that you need to do is you need to practice coding. You need to practice working with these functions, and that's not something you get from a book. That's why I would recommend to code and spend time on that. But in operating systems, will we be allowed to write in Rust? No, of course not. Operating systems in Rust is still extremely experimental, and I would not recommend that. I'm not using VS Codium. I said my main use of Visual Studio Code is writing text for papers, not writing code. Return key left the chat. What would you recommend we do if we also have such a problem you had while doing A1 and A2? I'm not sure which problem you are referring to. If it's the synchronization problem, we will cover that in the next lecture. In A1, don't have multiple threads that modify a global variable. If you have a global variable and it's modified by one thread, that's fine. If it's modified by multiple threads, that's a problem in A1. Do we have to write code on paper in the exam? Maybe, but if so, just a few lines. It would be maybe like 5 lines or so. How can I check if I stopped, canceled all threads at the end of the program? If you terminate the program, if you exit the program, all threads are gone anyway. We already mentioned that today. It was on the main page. If thread calls exit, or if the main returns, which implicitly calls exit, all the threads are stopped or cancelled. And with that, we go to the quiz. So I will close the Q&A. And I would like to know from you, do you still remember that analogy to program, process, and thread? If so, just write it. And if you have another good analogy, maybe also write that down. You can type that on your phone now, or in the Menti, wherever you opened it. Class instance method. Yes, I like that one. Yes, most of you, class instance method. Fußballspielmannschaften. I'm not sure this really reflects this analogy. There might be others. I mean, this is basically a mold. This is something you create from the mold, and this is something that is working within the object that you created. So it could also be a blueprint to construct a car. This could be the car, and this could be one of the many engines that you actually have in a car. It's not just the main engine, but you also have today have engines for, I don't know, the windows and many other things. So this could also be one example. But it has to have this notion of a mold, an instance that you created with this mold, and something that works within the resources, within the thing that you created. Okay, let's continue with the next one, and this will actually then be a quiz. Yeah. Did we have the same? This is not the quiz that we had last time, right? No, we had a different quiz last time. Where does program execution start? And you have 30 seconds. Start function, main or underscore start. Difficult. Okay, let's see what the result is. And most of you have answered underscore start, and this is correct. Underscore start calls the main function, and then we have the start function. The start function is only for threads, not for program execution, so it's a different case. The start function will be called when we start a program. The start function will be called when we start a thread. The underscore start function will be called when we start a program. Then we have the next question, and the question is, we can start. Can we start? Let's try again. Yes. Start quiz. Okay, fork creates an exact copy of the calling process except for PID, mutex state, semaphore state, or threads are not copied. Let's see, and I'm also moving back to this other view because I have another lecture right afterwards and need to move back to this other setup. Now the time is up. Yes, and most of you have correctly answered the PID is not copied. The other things are all copied, and therefore, well, threads, at least one thread is copied. For semaphores are copied, mutexes are copied, so they are exactly the same in the new process. So let me just arrange my things here again. And then we have the next question. And this might be, this is the last question, question number 3. Answer fast to get more points. And which of the following statements is true about fork by default? And here it says, the child knows the parent. The child can wait for the parent. The child dies when the parent dies. The parent has to wait for the child, or the parent does not know the child. And you have more time to think about that. 37 seconds left, so a lot of time. Of time left, 15 seconds, so you can go through all the answers. Time is up, and yes, most of you correctly answered the child dies when the parent dies. That's the case by default. The child actually by default cannot wait for the parent, and the child does not know the parent. It's a very cruel word. The parent has to wait for the child is also not true. It can wait for the child, but it doesn't. And the parent does not know the child is also wrong. The parent gets the PID of the child, so it knows the child. And with that, we get to the leaderboard. And yes, someone says in the chat, 90 subscribers left for monetization. Yes, of course, if you want to subscribe, you can click the subscribe button, and then we will, if monetization is possible, we will spend that on drinks at the SLP and operating systems final event that we usually have in January. Congratulations to BN, you got the most points and were the fastest to answer. Congratulations on that. And if there are any more questions, I will answer them now. And, yes, there was a quiz. So yes, in ESP we were never told never to use global variables. Is this just for exercise or are we allowed? You should use global variables all the time whenever they are useful to use. There's no, like, global variables are totally fine. They are actually in many cases better than other types of variables. If one thread exiting cancels all others, wouldn't that make it the main thread? But any thread can call the exit function. It's the exit function that cancels all other threads. Any thread can do that, so every thread then is the main thread by that logic. Okay. Please, more time to join the quizzes. Yes, I mean, you can join the Menti at any point during the lecture. The code stays the same all the time. So if you join that in the beginning, then you will be able to also participate in the quiz. Shouldn't be any problem. So I will then say, well, one more question. If every thread is the main thread, then none of them are. Yes, exactly. All threads are equal. With that, I would like to thank you and end the presentation here. So I will, yeah, I have to go back to an empty slide actually to, yes. And with that, we are at the end, and I want to thank you for your attention and see you maybe later this week. Maybe I have to schedule a lecture later this week. And otherwise, we see each other next week. Bye.